Okay guys, so today what we're going to be looking at is compound propositions. And today what I want you to be focusing on is learning how to identify conjunctions and disjunctions, which we'll talk about in a moment. And also we want you to be able to create truth tables of these different compound propositions as well. So to start off, let's do a couple of definitions. The first definition is a compound proposition. And a compound proposition is a statement formed using the word and or the word or. Okay? And the first type of compound proposition is called a conjunction. And that is two propositions formed using the word and. Okay? And the conjunction is only true when both of these individual propositions are true. Okay, so let's take a look at an example of a conjunction. And what we have here are two different propositions. Eli had soup for lunch, and Hugh, Eli had a pie for lunch. And the conjunction of that, which is denoted by this little caret, which looks a lot like the intersection symbol that you learned in sets, is P and Q, right? Which is Eli had soup and a pie for lunch. That's the conjunction of these two statements, right? These two propositions. So in this case, what we have here is a truth table. Now when we create a truth table with two different propositions, we want to cover all of the possible combinations of these propositions. So one combination is P is true and Q is true. Right? Another combination is P true, Q is false. Right? Another combination is P is false, but Q is true. And the last combination is both are false. Right? There's four different possible combinations of these two propositions. Right? Now, keep in mind that the conjunction is the combination of these two, and it's only true if both P and Q are true. Right? So in this case, P true, Q true, then P and Q is true. Right? If P is true and Q is false, then false. This is false, and this is false. So as long as there's one false anywhere between P and Q, then the whole conjunction is false. And if we think about it, that makes sense, right? Because the statement, Eli had soup and pie for lunch, means that Eli has to have soup and he has to have pie for lunch. So if he only had, say, soup for lunch, but he did not have pie, then this statement is not true, right? If he had, only pie but not soup, this statement is not true. This statement is only true if both these statements are true. If he had soup for lunch and he had pie for lunch. Okay, so now let's take a look at disjunctions, which is another type of compound proposition. And the definition is when two propositions are joined by the word or. So instead of or, we're using and. And a disjunction is true when either of the propositions is true. So it can be either one can be true, the whole proposition, the whole disjunction is true. So here's an example. We have Frank played tennis today, that's P. Q, where Frank played golf today. And P or Q, Frank played tennis or golf today. So this is a disjunction symbol, as you can see, and it looks a lot like disjunction. And this V symbol looks a lot like in sets when we had the union symbol, right? And it basically functions the same way as an or statement. So let's fill out the truth table for this. And generally for a truth table, we always start out the same. So if you remember in the last example, we had for P it was TTFF, and Q it was TFTF. If you have two columns like this, they're always going to start out like this. So you can generally fill out the beginning of a truth table exactly the same. You can memorize this. So for P or Q, remember, we check if either one of these is true, and the whole statement is true. So here we have, well, they're both true, so we're happy there. Here P is true, Q is false, but it doesn't matter. As long as we have one true, then the whole thing is true. Here P is false, but Q is true, so we're true over there. And only when they're both false is the disjunction false. So Again, let's think about this logically. The statement Frank played tennis or golf today is true if Frank played just tennis. It's true if Frank played just golf. It's true if he played tennis and golf today. The only time this statement is not true is if he did not play tennis, nor did he play golf today. Okay, so now let's take a look at our third compound proposition, which is called exclusive disjunction. And an exclusive disjunction is when two propositions are joined by the words or, but not both. So blank or blank, but not both. So it's called disjunction, but we have this word exclusive. And you can see the word or in it, just like disjunction does, but now we have the words but not both as well. Okay? So the exclusive disjunction is true when only one, exactly one of the propositions is true. So let's take a look at an example. We got P, Sally ate cereal for breakfast. Q, Sally ate toast for breakfast. Now P, exclusive disjunction Q. This is the symbol for exclusive disjunction. As you can see, it's just like the symbol for disjunction, but we add a little bar on the bottom. So Sally ate cereal or toast for breakfast, but not both. All right? So remember, we're looking for when only one of these propositions is true. So let's take a look at the truth table here. So P, Q, if they both are true, the exclusive disjunction is false. Okay? If P is true but Q is false, that's exactly one true. All right, you're happy? You got a true there, right? If P is false, Q is true. Yep, exactly one true. So we're true over here. And if they're both false, we have 0 trues, and we're false again over here. And it kind of makes sense, you know, if we look at this statement, Sally ate cereal or toast for breakfast, but not both. We want to say that she ate cereal, but not toast. That's okay. She ate toast, but not cereal. That's okay. But if she ate both cereal and toast, that directly contradicts this part of the statement, right? This part of the statement says that she did not eat both cereal and toast. And of course, if she ate neither of them, if she didn't eat cereal or toast, then this statement is also false. All right, guys, our practice problem for today. I have 2 statements for you, 2 propositions. Justin has a growth mindset about math. Justin has a growth mindset about English. First part, I want you to write 2 propositions, 2 compound propositions, P or Q and P and Q, and then I want you to create the truth tables for P or Q and P and Q. Okay? See you guys tomorrow.